Hi, and welcome to Air Engine Research. My website is dedicated to building, first designing and building a small, efficient compressed air engine that doesn't require any lubrication, any battery, any coolant, and something that just about anyone could build with minimal tools. Over the years, I've come up with a number of designs that did work, but I always have had problems with sealing, and mainly the valves. The last one that I completed was a 6-cylinder engine. It had a number of valves. They did work, but it ended up being a lot more complicated than what I want, and it's way, way, way too heavy. And too large. Back when I first started, I came up with a ring design. I tried that for a while. That worked okay, but it always used a center drive shaft that was used as a valve also, and that I could never get to stop leaking and just wasted way too much air. So I moved on to trying to design, the valves, and in so doing, I ended up making valves that worked from the outside and would have to have either cams or push rods or something like that to operate the valves. And also I realized that when I have a valve with air pressure behind a seal, in order to open that valve, you have to push against that air pressure, which puts a lot more strain on the engine, and it wastes a lot of energy that you could be used to make the wheels turn. If you've been following me, you know that I've worked on a number of different ideas, and at the present time I have two that I'm still working on. A bicycle engine, which is not going to be included in this video, but maybe the next one I'll use it as my main topic. But the one today is going to be an oval engine, and the valving and the design I've put together on it. It's a simple 4-cylinder compact engine that is equivalent to using a crankshaft with a 4-inch throw, which means it travels 8 inches from top to bottom. But that design uses way too much air because you've got 8 complete inches for each stroke. The oval engine that I'm working on, it only has a less than an inch stroke and is equivalent to that 8-inch stroke on the regular crankshaft. And I'm thinking it might have more power in total because of the design. You'll have to see the design and what I'm working on, but today's video is mainly going to be about the valves and how I've come up with a way to seal the crankshaft, which is also the valve in this type of engine. I don't have it completely finished yet, and I'll have to see if the material that I'm using to seal the body to the crankshaft, whether it actually is going to be sturdy enough and wearable enough to be efficient. But at least I'll show you what my design and idea is. So why don't we go ahead and see what I put together for you for today. But before I do go, I'd like to say if you have found this video for the first time and you'd like to be notified on future videos of what I'm doing and how things are working out, if you subscribe and punch the little bell symbol, you'll be notified whenever I put out a new video. And for you longtime subscribers, thanks for hanging in there with me, and hopefully one of these days I'll come up with a good, efficient, actual design that I can put on my test vehicle and go drive down the road. So let's go ahead and get back to the video. I'm out in the garage today for the first time to be able to work, I guess, in several months. It's just been too cold. So I've been doing a lot of drafting and designing, trying to come up with a good, efficient way to build this rotary compressed air engine. Or I should say it's an oval, not a rotary. It does rotate, but it's not round. It's an oval ring that rotates around the center square body and cylinders. The basic design is being worked on, and it changes over time. Each time I try putting the parts together on paper, there seems to always be some kind of a problem that I have to overcome. I've got it down pretty good, I think, now. The main problem that I've had over the years with the designs is sealing. Compressed air is very precious. We don't have much, and you have to take it with you. So it's got to be something that is sealed to preserve the air and, let it be useful rather than just wasted and blowed out. The basic design is this design. It has 4 cylinders. It has an oval ring that goes around the outside. Now this particular paper is probably a couple of months old with the design that's on it, but it's basically the same. It has 4 cylinders and an oval ring. It has a center drive shaft that also acts as a valve. Now, the characteristics of this design means that there's 2 cylinders that fire all the time. These 2 are ready to fire. These 2 here are in the exhaust mode. As the ring rotates, it will push the 2 exhaust pistons back in, and the 2 pistons in this direction expand. So when they're expanded, it'll look more like this. And as it rotates, it pushes and pulls the pistons in and out. And I've had many problems trying to figure out how to make a seal. And in the past, I've always thought there must be some way to put a seal on the inside of the block. Now I've got the block now that's going to be the center block. I'm working on it. But it looks like this, and it's going to have 4 cylinders attached to the 4 sides of it. The shaft goes through the center. And like I say, in the past, I always thought you'd have to try to get inside and put a seal in there, but I could never figure out how in the heck to make the inside accept a seal, and what's going to keep it from tearing or whatever when it rotates the shaft on the inside. Well, I finally realized that if I make a adapter with an insert that goes into it, I can put a seal in it, and that little adjuster, I can screw it in, and then the shaft, the seal will push the adjuster will push the seal up against the shaft, and I can make maybe a half-inch seal rather than like an O-ring or something trying to get in there, which would not work. It would be tore up every time the shaft would rotate. But with the Teflon or ultra-high molecular density plastic, I can make a seal that'll rotate, or that'll allow the shaft to rotate and won't tear it up. And then the cylinder would just screw on to the outside of this thing here, screw it right on. The piston goes in it, the ring goes over the top of it, and basically you've got the engine completed. Well, we'll see how that goes. Today I'm working on the square center hub of the rotary 4-cylinder engine that I'm working on. This particular engine will be a screw together. All the component parts you can individually screw the parts together, starting with the center block and the 3/4 cylinder to square block connectors, which are 3/4 inch with 1/2 inch IDs, where the adjusting seal goes in. That is threaded with a notch so you can screw it in. And internally it is 1/2 inch. Halfway in from this end, it'll be reamed out to 1/2 inch. The other side is 1/2 inch threaded. There will be a hole in the 1/2 inch insert, 1/4 inch in diameter, that goes through to allow air to go through the connector, and then the UMDF seal will be inserted from the back side, and then the entire thing will be screwed in like it is up here. At that point, the shaft goes into the center, and this part here screwed in will push the seal up against the shaft. That was the only way I could figure out how to seal that. I was always looking at it with the idea that it had to be sealed from the inside, but that's not true. I finally realized that making this, putting the seal in it, and then screwing it in, and then adjusting the inside to push up against the shaft would work. So that is in theory. Since I've been working on this thing for the last several months, I've gone from many different versions of it to many more versions. This one was probably a month or so ago that I was working on it. It did work, except the seals. The inside seal area, when it was running, would leak from this cylinder over to this cylinder, which you maybe can't see that, but it would stop the engine from working. It would go partially and then counterbalance it, and the engine would stop. So I had to come up with some kind of an idea that would allow me to put the seal on the shaft to keep that from happening. Now, hopefully, the design that I have now will work. But until I actually try it, there's no way to know. When I get this block completed, I'll be able to at least check the seal and see if it will seal the inside of the shaft to the block. So for now, I'm going to go ahead and continue working on making the individual parts. I've got one more partially done. I have to cut it off and then make one more of this seal, or this part rather, the 3/4 inch by 1 1/8 piece. Once that gets done, then I take the 1/2 inch piece and basically cut it off, drill a 1/4 inch hole in it, put a slot in it like that, as you can see here, and then that part will be finished. If I wanted to try it, I guess I could. Well, maybe I don't need to. I was going to say I need to put some way to put air into that, but that's not true. I'm going to have to take the shaft and put the shaft inside the hole, like so. And the shaft is the part where the air is introduced into the block. If the seal seals it, I should be able to go in between the two cylinders, and the air should be blocked off by rotating the shaft from one cylinder to the next cylinder. The in-between should be blocked off and no air should flow. Then I will know if the seal works. If not, back to the drawing board. This shaft has a bearing on both sides. So it's possible, I guess, to have a machinist make this block for me and have basically zero clearance between the block and the shaft. But the only problem with that, if the shaft rubs on the block, then it has to be lubricated. My intention was to make it so that you do not need lubrication. Now, I'm not sure just how much clearance, like maybe 1 or 2 10,000ths or whatever, would be airtight. I just don't know that. But unless it is airtight, the problem with bleeding from this cylinder into this cylinder as the shaft rotates is a problem. If this entire engine does work the way I hope, you'll be able to basically do like when you buy a little cabinet, they give you the parts, a screwdriver, a wrench is required, and you just screw it all together. When you're finished, you've got a engine So we'll see how that goes. These are basically the parts that I've been using to make the things that I'm working on now. I try to keep a tidy little desk so it doesn't get too cluttered up, but in order to make this video, I had to clean it up because it was cluttered. So for now, I guess I'll have a drink of coffee and go out and cut this last piece that I have finished and then make one more. So that's going to be it for this particular part of the video. The next project will be to make the next project will be to make the UHWM seals that go inside of the 3/4 connectors. So I'll be starting to turn those down and then cut them to length and shape the end for matching the shaft. But that'll take a little while, so I guess I better get started. This morning I started working on finishing up the valve and the center block for the engine, and I got all the little parts and pieces done now for the valve system and the connector to the center block and the cylinders. So the next thing I'll be doing is assembling all of it, I guess, and I do have to thread the drive shaft cap that the air lines are connected to feed the air into the drive shaft that goes to the center body and then into the cylinders. But once I get these small parts assembled, and I'll maybe try to put that part together, and then I have to work on the cylinders. I'll make those and be pretty far along. One day soon I hope to be able to try the air engine and see if my valve system and seals works. Until then, it's still all theory that it should work. We'll see. But before I do go, I'd like to say, if you have found this video for the first time and you'd like to be notified on future videos of what I'm doing and how things are working out, if you subscribe and punch the little bell symbol, you'll be notified whenever I put out a new video.